Hi guys. Today you're going to be looking at a video. I'm here in the classroom, and so hopefully the sound is okay. And you're going to be looking at a video about lines and slope, and this should all be very familiar to you. You've been doing these kinds of things since Algebra 1. So hopefully this won't be too bad, and you'll have an assignment today, and then you'll have another assignment on Thursday over kind of the same stuff. So just one day of video, and then we'll go from there. So, and I'm going to see how this works. I don't know. We'll see. Okay, so this really covers two sections in your book, section 2.3 and 2.4. Obviously, we've skipped over 2.1 and 2.2. We'll talk about those another time. So we're going to talk first about slope and thinking about what is slope. A lot of times people say, oh, we know it's rise over run, or you might remember the formula for finding the slope. And there it is. The slope is y2 minus y1 over x2 minus x1. And we're just going to look at a quick example of using that slope formula to find the slope. Remember, the important thing is to keep your subtraction straight. So if we have y2 minus y1, if I call this y2, it'll be negative 2 minus y1, which is 4. Then when I do x2, I have to start with this point, which will be 2 minus then negative 3. Well, negative 2 minus 4 is negative 6. 2 minus negative 3 is the same as 2 plus 3, so that's 5. So our slope is then negative 6/5. Okay. I forgot to mention that a lot of these notes, I pre-wrote them a little bit on the board so that we wouldn't have to take so much time on the video, but if you need a chance, go ahead and pause the video so you can write things down. Let's talk about some different types of slope. We have a line that is going in this direction is what we would consider a positive slope. A line going in this direction would give us a negative slope. This is a horizontal line. A horizontal line has a 0 slope, or the slope would be 0. And a vertical line has a slope that is undefined. So those are 4 different kinds of slopes that we have. Then we talk about specifically equations of lines. There are several different forms of equations of lines. We're going to talk about 3 of them. The first one is point slope form. Point slope form, you may or may not recall, is y minus y1 equals m times x minus x1. That is the generic form for that. And point slope form is nice because if we have a point and a slope, then we can write the equation of a line. That's why it's called point slope form. So this is the line going through x1, y1. So that x1 and this x1 and y1 would be the ordered pair that we are given. That has slope m. Okay, and again, of course, little m always represents slope. Okay, then we have slope-intercept form, and this is the one that is generally the one that people remember. Y equals mx plus b. This is a line going through point 0b, so that's a y-intercept, has an x value of 0 and some sort of b value there, or y value, with slope m. Okay, and so that's our slope-intercept form. And then we have another form called general form. General form looks like this: capital A x plus by plus c equals 0. And general form we don't see quite as often. We'll talk a little bit about it here in a minute. We just don't see it as often because it's not very useful. And we do need to say on this one a couple of things. Both A and B cannot be 0. Okay, If A and B are both 0, then all we really have is C equals 0, and that doesn't make any sense for an equation of a line. So these are the three different forms of equations of lines that we talk about. However, as I slide the computer over, what we do know is that every line has a distinct slope-intercept equation. And when we say distinct, remember that distinct means different, okay, unique. So every line has a distinct slope-intercept equation. That's why we like slope-intercept form really the best, because it is unique to each line. So when we're writing the equation of a line, generally what you'll be doing on your assignments is starting with point-slope form and then changing it into slope-intercept. So we'll look at a couple of examples here. The first one, write the equation of the line through the point -1, 3 with a slope of 4. So we're going to start with that point slope equation where we have x1, we have y1, and we know m. So we'll have y minus the y value of our ordered pair, which is 3, equals m, which is 4, times x minus the x value. Be really careful there. It's x minus -1, which is really, we know, going to turn into x plus 1. Then we need to change this into slope-intercept form. We do that by getting y by itself. But what I need to do first, and these steps are pretty much always the same, we're going to distribute. So we'll get 4x plus 4 on the right-hand side. And then we need to get y by itself by adding or subtracting. In this case, we're going to add 3. So y equals 4x plus 7. And that is the equation of the line through the point -1, 3 that has a slope of 4. Okay. The next example we have, hopefully, I'm going to work on those blinds here in a minute. Write the equation of the line through these 2 points, -2, -1, and -1, -6. This time I cannot go directly into a slope-intercept or point-slope equation because I don't have the slope. I do have 2 points. Since I have 2 points, we can find the slope. So that's what we'll do first, is find the slope. So we'll start with, I'm going to do -6 minus -1 over -1 minus -2, or -6 plus 1, which is -5, -1 minus -2, which is -1 plus 2, which is +1. So we have a slope of -5. Now, to write the slope-intercept equation, we need to use the slope and one of the points. It doesn't really matter which point you choose. I would say that if I had a point that had no negatives, I would choose that. If I had a point that involved a 0, I would use that. I don't have that in this case, so it doesn't really matter. I might choose the point then that has smaller numbers, which would be -2 and -1. So I'm going to write the equation. So we're going to have y minus -1 is equal to m, or -5, times x minus the x value, which is -2, or that's really y plus 1 and x plus 2. So we have y plus 1. Again, we'll distribute, so we get -5x, and we get -5 times 2 is -10. Then we'll subtract 1 on both sides, so we get y equals -5x minus 11. And that is our slope-intercept equation of the line that goes through the points -2, -1, and -1, -6. Okay, now we're going to talk about horizontal lines. We know a few things about horizontal lines. The first thing is that they do have a slope of 0. We talked about that earlier. So if we think about having a slope of 0 and a slope-intercept equation, then y equals 0x plus b, or, of course, 0 times x is just 0, so we are talking about an equation that looks like this, y equals b, and b is the y-intercept. Also, what we can know is that the equation y equals 3, for example, is the line whose points all have y values of 3. So if you cannot remember, like, ooh, I can't remember, does a horizontal line say y equals or does it say x equals? I can't remember which variable it is. you can always look at a graph and think about, well, if I have a horizontal line, for instance, I have all of these ordered pairs on a horizontal line, right? And if I think about just what their ordered pairs are, this one is 1, 3. This one is 2, 3. This one is -1, 3. This one is -2, 3. And you can see that all of the ordered pairs along this line have a y value of 3, which is why then the equation is y equals 3. In contrast, we talk about vertical lines. Okay? Vertical lines have slopes that are undefined. You will know that you have a vertical line when you're looking at the slope between 2 points. If you have 0 in the denominator of that fraction, that's going to be undefined slope. And we have points on a vertical line all have the same x values. So the equation is in this form, x equals a. We can't really equate that to a slope-intercept equation at all because we can't really put undefined in place of m. So when we have, for instance, I just graphed a quick vertical line here. If I think about ordered pairs all along this line, this vertical line, right, we would have things like -2, 1, -2, 2, -2, 3, -2, -1. This one would be -2, 0. Right, and you can see that all of these ordered pairs have the same x value. Their y values are changing, but we would call this line, I'll write it down here, x equals, -2. Okay, so that's the difference between writing horizontal and vertical lines. Now, we did not talk about graphing from slope-intercept form. I assume that we're all okay there, hopefully, crossing my fingers, because you're going to be doing some today on your assignment. But we do need to talk about intercepts a little bit. And I said that we would talk a little bit more about general form, and this is it. A lot of times if you have an equation that happens to be in general form, the easiest way to graph from general form is to use intercepts, to find the x-intercept and the y-intercept. And if you think about an x-intercept being a place where we cross the y-axis, what we know about all points on the y-axis is that their y value is 0. So to find an x-intercept, we're going to let y equal 0 and then solve that equation for x. And in the same way, to find a y-intercept, we're going to let x equal 0 and solve for y, because all points on the y-axis have x values of 0. Okay, so we'll look at an example here. Graph using intercepts. So we have this equation that is in what we might call standard form. Move this a little closer. There we are. 4x minus 3y minus 6 equals 0. This is in general form. I think I just said standard form. But this book calls it general form, so that's what we'll call it. So I'm going to do this by finding the x-intercepts, and I'm going to find the y-intercept, and I'll usually kind of label those. To find the x-intercept, I'm going to make y 0. So 4x minus 3 times 0 minus 6 equals 0. Well, 3 times 0 is just 0, so really I have 4x minus 6 equals 0. Add 6 to both sides to get 4x equals 6, and then divide both sides by 4, and then we need to reduce that. So 6 over 4 is 3 halves. Therefore, the x-intercept is 3 halves, 0. The x-intercept is written as an ordered pair. It's a point. Okay. Then we would have our y-intercept. We need to make x 0. So 4 times 0 minus 3y minus 6 equals 0. Well, 4 times 0 is nothing. So I have negative 3y minus 6 equals 0. Again, add 6 to both sides, and then divide now by negative 3. Y is negative 2, or the y-intercept is 0, negative 2. Okay, so those are our intercepts. Then we'll think about graphing those. So I'll just sketch a graph quickly here. And we have an x-intercept, we said, of 3 halves 0. That's like 1 1/2. So we go over 1 1/2, up or down 0. We have a y-intercept of negative 2. So we're going to go down 2 on the y-axis. There it is. And I'll just quickly draw that line in. And there we have our line that we graphed, and that is from general form. All right, we have one more topic that we need to talk about, parallel and perpendicular lines. So let's talk about what we know about parallel and perpendicular lines. Parallel lines have the same slope. That is their main feature, is that they have the same slope. So if I have a slope of a line that is 1/3, the slope of the line parallel, and I'm going to use this symbol to represent parallel, right? So the slope parallel to that is also 1/3. If I have a slope that is 9, the slope of the line that's parallel to that is also 9. So that should be fairly straightforward. We run into a little bit more challenge when we talk about perpendicular lines. They have slopes that are opposite reciprocals. So there's two things going on there. Opposite, one meaning positive or negative, reciprocal meaning that we're turning that fraction over. So if I have a slope of, for instance, let's say 2/3, the slope of the line that's perpendicular to that is its opposite. This is positive, so it will be negative. And the reciprocal of 2/3, so turn that over, would be 3/2. If I have a slope of -2, okay, the slope of the line perpendicular to that is the opposite of negative, which will be a positive. Sometimes I might even write the little plus sign there just to know that I've thought about it. And then the reciprocal of 2, remember that 2 is really over 1, so the reciprocal of 2 is 1/2. Okay, so hopefully that makes sense. So we've got just a couple of examples here. First one, write the equation of the line passing through the point -2, 5, that is parallel to y equals 3x plus 1. So I know, remember to write the equation of a line, we need a point, and we have a point. It is -2, 5. And we also need a slope. They did not give us the slope, but they gave us information about the slope. They told us that it's parallel to this line. This slope we can find right here. This is a y equals mx plus b equation. So the slope of this line is 3. Therefore, the slope of the line I'm talking about is also 3. So now that I have a point and a slope, we can write a point-slope equation, and hopefully you're very good at those at this point. And we'll change that into slope-intercept form by distributing and then adding 5. So y equals 3x plus 11. Okay. Next we have this one. Write the equation of the line passing through the point -2, -6 that is perpendicular to this line. Well, again, we don't have the slope, which is what I would need to be able to write the equation of this line, but I have information about the slope, okay? But we need to find the slope. I don't know it yet because this is not in slope-intercept form. This is in general form. So I'm going to take my general form equation that I was given, and I'm going to solve it for y. I'm going to get y by itself because, again, if I can get y by itself, then I've got it in slope-intercept form. So to get y by itself here, I'll do a couple of things. I'll probably subtract x and also add 12 on both sides so that I have 3y is equal to, you can call this -x plus 12. Then we need to divide both sides by 3. But when I do that, I have to divide everything by 3, which then gives me -x divided by 3, or -1/3 x, plus 12 divided by 3, which is 4. So now I know that the slope of this line is -1/3. Whoop, There it is, because it's in slope-intercept form. But I need the slope of the line perpendicular to that one. So my slope is going to be the opposite. It's going to be positive, and the reciprocal of 1/3 is 3. Okay. Now that I have a point and a slope, I have enough information that I can write the equation of this line. So I'll have y minus the y value of the ordered pair is equal to the slope, which is 3 times x minus the x value of the ordered pair. And then we change this into slope-intercept form, again, by distributing. So that's 3x plus 6. And then I'll subtract 6 on both sides this time. So I get y equals 3x. Plus 6 minus 6 is 0. So I really just get y equals 3x. Okay. So that's going to be information about writing equations of lines that are perpendicular. Okay, so let me kind of tell you what's going to happen. I'm going to give you an assignment now that's going to cover writing equations of lines. Some of the beginning stuff, so we'll have vertical and horizontal line equations. You'll be doing a little bit of graphing. And so if you want to grab some graph paper, it's in the tray on the side of on the shelf on the side of the classroom. You can get some graph paper. And then on Thursday, I think is the next time you have this class, I hope. On Thursday, you're going to do another assignment that's going to have more to do with the parallel and perpendicular lines. Okay, so the assignment for today, but no more notes on Thursday, so that's nice. So the assignment for today is in section 2.3. It's on page 267, 2 through 72 even. There are copies of the book page that can be handed out, so you'll all have a copy of that. The books have been ordered, so hopefully when I get back next week, I'll have a chance to go down to UMKC and get them. We'll all have a book. But in the meantime, you'll have a copy of the page. Again, like I said, you'll have a different assignment on Thursday. Work hard, have a great week, and I'll see you on Monday.